We shall be looking at a new topic, the change of subjects of the formula, which is also called transposition. Now, for this lesson, we shall look at it in different sections. So, first by introduction, by relations involving linearity, when it involves brackets, when it involves fraction, powers, and roots. Now, to make subjects of the formula means to rearrange an equation so that the required letter gets isolated on one side of the equation, which most times is to be on the left hand side, but it is optional and it's not compulsory. But more conventional, it is meant to be on the left hand side. Now, there are no particular formula to this topic. It does not require any formula. You just need to know some steps. Yes, you just need to know some steps, and it requires a formula at all. So, to change or to make subject formula, first of all, rearrange by placing the letter to make the subject on the left hand side. Yes, that is the optional. That is, if the letter the next subject is on the right hand side, you can still rearrange it to be on the left hand side. So, whenever you have roots, fractions, and brackets, just clear them off. And if the new subject, that is, if the letter you want to new subject is under a root sign, yes, just take the reciprocal again on both sides. So, on both sides of the relation, just to clear the roots and powers involved. And so also, whenever you have a fraction, like I said before, you have to clear the fraction by multiplying the fraction by the LCM. So that is, if it is more than one fraction, yes, you multiply by LCM. But if it's just only two fractions, one on the left and one on the right, you just need to cross and multiply. Yes. So when you have brackets, just simply multiply them out. Just multiply all brackets out. Now, after that, you collect the terms containing the new subject letter on one side of the relation or equation, and then collect together all other terms on the other side. And this will help us get rid of the unwanted quantities. The term to the next subject must be on one side. Yes, if you're asked to make that subject, let every x be on one side. And you're asked to make E subject, let every letter and the name E be on one side. While the rest that does not have that letter to the next subject should be on the other side. Now, you factorize the terms on each side of the relation, that is, it is factorizable. Yes, factorize the terms on each side of the relation, that is, if it is factorizable, you isolate the new subject letter on sides of the relation. This is done usually by dividing the other factor in the term. So the answers can be represented any form. Yes, the answers can be represented in any form. And to have different form of answers, that is mostly in fraction. We have different form of answer mostly. This one works mostly in fractions. Just multiply the numerator and denominator by -1 and it will give you a different form of answer. Yes, but this one works very well for fractions. So we're going to see different examples of how we can apply these steps as mentioned.
Now, let's look at the first set of questions, relations involving linearity. So, we have the first question, make H the subject of the formula in A equals to BH. So, to solve this problem, we are asked to make B the subject of the formula. We are asked to make B, sorry, we are asked to make H the subject, make H the subject of the formula. So, we know that we need to get H. But as you can see, the terms we have on the left hand side is just only A. On the left hand side, we only have A, while on the right hand side, we have B and H. We have B and H. And like I told you, anything we are asked to make subject should always be on the left. So let's just quickly rearrange. Rearrange this. Then by rearranging here, I mean let all the right hand side become the left, and let all the left become the right. That is BH should be on the left, and on the right we have the just rearranging and not crossing anything. So to get my H, the only way to get H is to divide both sides by B. The only way for H to be gotten is just to divide both sides by B. And as you can see, B will cancel out B. So therefore, our H becomes equals to A over B. And that's the answer. So let's look at the second question. Make Y the subject of the formula in X plus Y equals to Q. Now, to make Y a subject here, make Y a subject. So, as you can see, on the left hand side, on the left here, we already have the term we are looking for. The term we are looking for is already on the left hand side. So, there's no point trying to rearrange again here. Yes, since the Y you are looking for is on the left hand side. So, since it is already arranged, and I'm going to move X. X should be the term, but I'm going to move away X. So, it then means that I need to cross X to somewhere on the right hand side. Yes, so that I can get my Y. So, and if I do that, if I choose to cross X over, I'll have Y left. I'll have Y left on the left hand side. And over to the other side, I will have just Q. Since I'm moving X is positive. Yes, there's a positive sign that is invisible at the side here. So once it changes and crosses over, it becomes negative X. And this is our answer for this question. And that's all. Now let's see the third question. Make T the subject of the relation and X equals to AT plus 4. AT plus 4, X equals to AT plus 4. Now for this question, notice that the left hand side, is containing only x, and the right hand side is containing 80 and plus 4. So we have to make t the subject, and like as we know, anything that has a mixed subject should be on the left. I think not that, it's not rational, it's a choice. So it's not compulsory. But for learning sake, put everything that has a mixed subject on the left hand side. So since I have t that I want to make subject on the left hand side, I'll have to rearrange it, turning out the whole left to become right hand side and turning out the right hand side to become left hand side. So as we have here now, it is now rearranged. 80 plus 4 is now on the left, while x on the right. So our major concern is to make t the subject. So what needs to go away first to make t the subject, or to make t to be alone? Obviously it is plus 4. It is plus 4 that should go away first. So if I cross plus 4 over to this side, now I will have at equals to x plus 4 is no longer on the left hand side. Now I'm going to cross it over, it becomes minus 4. Whenever you cross the term, whenever you cross, I did not say whenever you rearrange. For rearranging, it does not involve changing signs. But whenever you cross the term, you always change the sign. I've crossed 4 over, it can become negative 4. Now, the next step to do is, how can we get t? For t, because a must go away. And how can a go away? By dividing both sides by a. Dividing both sides by a. So that a will cancel out a. And I will have t left. My t becomes equal to x minus 4 all over a, and this is our answer. Now at times, of course, this is our answer for this question. If everything here is our answer, but at times you could have a different form of answer. Whenever you have fractions, most times you can have a different answer. Like for this one I have here, t equals to x minus 4 all over a. Now if you multiply the numerator and denominator by minus 1, it gives you a different form of answer, and do still the same thing. How do I mean? I have t equals to, now multiply the numerator and denominator by minus 1. Minus 1 multiplies the numerator x minus 4 all over minus 1 multiplies just e. Now it gives us a different form of answer. So we have t equals to minus 1 times x here is minus x. Minus 1 times minus 4. Minus 1 times minus 4. And minus transit minus is plus. So we have plus. Then 1 times 4 is just 4. All over minus 1 times a is minus a. Yes, so I can have this also as an answer. So this expression here, or equation t equals to minus x plus 4 over minus b is still an answer to this problem, which can be written in this form also. You can choose to write with positive 4, this plus 4. You can choose to write it first, plus 4, and then followed by minus x, then followed by minus x, all over minus b. And as we know, plus 4 is good as me saying 4. Yes, plus 4 can be equal to just 4, then minus x, all over minus 3. So this can also be an answer for this. Now let's see the first question. Given that b equals to b plus 80, find a in terms of b, u, and t. We are just to make the subject of the formula here. Now, as you can see, on the left hand side, we only have v there. On the right hand side, we have, on the right hand side, we have u and plus 80 on the right. Now, the term I'm asked to make subject is on the right hand side. So I can shift to the right or rearrange by writing all the right hand side on the left. I can choose to write all the right hand side to the left. And putting half in here. Putting all the left hand side to the right. Now, don't forget what you asked me to do is A. So to make A subject here, I need to move U first. U must go out first. Yes, and don't forget that U is having an invisible place here. So when this U comes to the right, if I move plus U to the right hand side, if I move plus U to the right hand side, I will have just A left there. I'll have A and T remaining on the left hand side. Since U has been moved to go to the right, it becomes minus U. Yes, it becomes minus here. And to get my actual A, which I'm looking for, to get A, I'll have to divide both sides by T. Yes, to get A, I'll have to divide both sides by T. So that T will cancel out T here, and I'll have A. I'll have A to be equals to V minus U over T. And this is the answer. Now let's see the next question. We have to make T the subject of the relation with 2T minus X equals to U plus V. Now, we are lucky enough, and T, which we are asked to make subject, is on the left hand side already. Yes, so there's no point here trying to rearrange. Since T is, if we have the T on the left hand side, while on the right hand side we have U plus V. On the left we have 2T minus X, while on the right we have U plus V. So to make T the subject formula, I need to take minus X to the right hand side. Minus X needs to go to the right hand side. So I'll have 2T Yes. So since I want to take minus s to the right hand side, I will have 2 to the left, or remaining on the left hand side, equal to put down the right hand side value. Now minus s will leave the left, and cross over to the right and become plus x. Yes, because it's negative on the left hand side. When it now crosses over to the right, it becomes positive. Now, how do we get our t here? In a simple way, just divide both sides by 2. Divide both sides by 2, and you have 2 cancel itself. 2 will cancel itself, and I will have 2 remaining, and this is equal to u plus v plus s all over 2. So since this is a fraction, we're going to have different answer. Like by multiplying the numerator by -1 and also the denominator. So we will have a different form of answer, although we're still saying the same thing. Now let's look at the next question. Make m the subject formula in mt plus n equals to mp plus q. Now, as we can see clearly, the left-hand terms are these, and all the right-hand terms are these here. Now, you have to make m the subject, but m is found on both sides. Here, as you can see, we have m on both sides of the equation. So, there's no point rearranging, because even if you rearrange, you still have m on both sides. Because the main aim why we rearrange is so that we can have the letter term on one side. Yes, that is one of the question. So whenever we observe that the letter term is on the right hand side, it's best to rearrange for it to just go to the left. But in this case, when it's on both sides, even if you rearrange, you still have it on both sides. So the best thing to do is to collect like terms here. Yes, collect like terms. Because you can't rearrange here, because rearranging here, you still have m on both sides. Like, this is what I mean. If I choose to rearrange, I'll put all the right hand side to the left, and I'll have mp plus q equals to, then the left hand side I'll put them in the right, and I'll have mt plus n. And as you can see, obviously there's not changing anything, because I still have m on the left hand side and I still have m on the right hand side. So the best way to do is to collect like terms. Now, to collect like terms, I'll bring every m to the left hand side, and I'll have m, and I'll have mt. I have an m term on the right hand side here, that is mp. But if mp crosses and come over to the left hand side, it becomes negative, because it's positive here. It's carrying a plus sign that is invisible. So when it crosses to the left hand side, it becomes negative. Negative mp. Negative mp. Then you don't have any term containing m. Nothing again has m here. So others should go to the right hand side. And I have this equals to. On the right already we have q, so we should remain there. And we have n on the left. N does not contain m. Like I said, I want to put all the terms contain m on the left. But if no term has m, now take it to the right. So n should go to right. N is positive as you are seeing here. When it comes to the right, it becomes negative n. And at this point, what should we do here? We have mt minus mp. So we need to factorize. What does these two sides have in common? These two terms, mt and mp. What do they have in common? They have m in common. They have m in common. Although most times if you want to get it, if you don't know how to, if you don't know why they have m in common, you can solve by HCF. How do I mean? Let's find the HCF of mt, and mp. Let's find their HCF. What can divide mt and mp at the same time? M should do that. M divide mt by this. This mt divided by m. Yes. Mt divided by m. M will cancel out. And as you can see, we have t left. Put down t. Now, let m divide mp like this. Mp divided by m. M will cancel m here, and I have p left. See down here. Now, what can divide t and p at the same time? Nothing can divide. So, we stop. This is HCF, we stop. So, while stopping here, you observe that the only thing that can divide both terms at the same time is m. And this is why I said m is common to these two terms here. So I'll bring out m, and then the rest should be in brackets. You see I have t here. Let's put the t in brackets here. And the sign between them is negative. So, negative. And also put the second letter here, p. And then you close the bracket. So, equals to q minus m. Now, what can we do to get m? I want m to be alone. How can we get m? To get m, I must take away this bracket term here. It needs to go away. This bracket term needs to go away. So how can we go away? It's by dividing both sides by that bracket term, that is t minus p. Dividing both sides by t minus p. The t minus p will cancel t minus p. Then we have m left. And m becomes equal to q minus m all over t minus p. And this is the answer for this question. Now, you could have a different form of answer, just like we've been doing. To have a different form of this answer, I will have to multiply the numerator and the denominator by -1. And I will have m as equals to. So, I'm going to multiply the numerator by -1. So this -1 should multiply the numerator we have, that is q minus m all over. You can also have the denominator being multiplied by -1, that is t minus p. Doing this, I will have a different form of answer, although they're saying the same thing. So, we now have n as equal to Now, minus 1 times q. Minus 1 times q is minus q. Minus 1 times minus n. Minus 1 times minus n. If minus multiplies minus, it becomes plus. Yes, it becomes plus, and then 1 times n is n. So minus 1 times minus n is plus n all over this is the same thing. Minus 1 times t is minus t, and minus 1 times minus p is plus p, of which I'm done, and I can write this expression by saying that my n is equal to I can choose to write this positive n first, that is n is positive, and then negative q, all over writing p first, that is positive p, and then negative t. So these two answers are the same. These two answers are the same. So you can have your answer like this, or you can have your answer this way. They are both correct. Now let's look at relations involving brackets. So make P the subject of the formula in Pt minus PQ equals to 2 open brackets P plus L close brackets. So yes, now as you can see, we have P on both sides, so there's no point rearranging. Whenever you encounter the term, you are asked to make subjects on both sides. There's no point rearranging. Yes, no point rearranging. Unless the term is found only on one side. Yes, maybe it is found on the right hand side, then you need to rearrange to the left hand side. Yes, you only rearrange when it is not at the place you want it to be. But if it is on both sides, you don't have to rearrange. So we want to make P. So as you can see, this P on the left hand side is showing itself, and as well the P on the right hand side. But the P on the right hand side is in brackets. So we need to find that P also. I must open the bracket to bring out the P. Whenever a term you are looking for is in a bracket, whenever it is in a bracket, always expand the bracket. Anything you are looking for, once it is in a bracket, open that bracket, break it, and I will have 3t here minus my P, and then Q equals to. Now open the bracket. 2 times P is just 2P, and 2 times L there is positive 2L. Good. Now, as you can see, we need to collect like terms. Yes, we need to collect like terms. So let's take like terms in P. So bring all the P's on one side. Bring all the P's on one side. And I will have my answer to be minus PQ, which we have here, minus PQ. Now, bringing 2P to the left hand side. 2P is on the right hand side, so take it to the left hand side, becomes minus 2P. Becomes minus 2P. Now, having done this, take every other thing that does not have P to the right hand side. Already we have on the right here, we have 2L. But 3T is on the left, so it's positive here. You can see it's positive. So if 3T comes over to the right, it becomes negative. We have minus 3T. Now, having done this, as you can see, let's now So rise. Since we have P now, as you can see, P is common to both sides, just as we did in the previous part. Now, and as you have, let's bring back minus as well, since minus is common to both PP and 2P. They have minus in common, so bring it out. If I bring out the minus, now what else do they have in common? They already have P in common. Bring out the P. They also have P in common, so bring out the P. Now put the rest things in brackets. Put the rest things in brackets. So let's see what you do in the brackets now. The first term up here is minus PQ. Minus PQ. That is the first term. The first term here. Now minus PQ should be divided by this common term outside the bracket. That is minus P. I want to divide minus PQ. That is the whole of this. Minus PQ divided by the common factor minus P. It becomes the minus, you cancel minus plus, P will now cancel P, I now have Q remaining. Also, do the same thing. The second term here is minus 2P. So, I have minus 2P. Minus 2P should be divided by this common factor minus P. Divided by minus P. Minus P minus divided minus plus P we cancel P. We have plus 2 left. So I'll have plus 2. Then we place the bracket. So I'm then factorizing. So on the right hand side we have 2L minus 3T here. So the final thing to do is to get P. What needs to go away for us to get our P? To get our P, I must take away this minus sign here, and also this term in brackets. They need to go away. Yes, so how can they go away? They can go away only by dividing both sides by that minus 10, and also by the bracket Q plus 2. Minus divide both sides by Q minus Q in brackets. Sorry, minus open bracket Q plus 2 in brackets. So the minus we cancel minus, I have plus Q plus 2, we cancel Q plus 2. What do we have left visible? We now have our P. Our P is now getting, P becomes equals to 2L minus 3T all over minus open bracket Q plus 2. And this is our answer for this. So, but you can, as we've been doing whenever we have fractions, you can have different form of answers. Someone can have this as an answer, P equals to 2L minus 3T over minus open bracket Q plus 2 in bracket. And someone else can have this as an answer to be like this. So, let me explain this answer here. I have P. This method works for all of them. If you want to involve fraction, you can have different form of answer. So I have P equals to 2L minus 3T all over. Let me open this bracket down here. Use minus. Of course, there is no number here, so I can assume there is a 1 inside the bracket. So this becomes minus 1. So let's now open this bracket with minus 1. Minus 1 times q is minus q. Minus 1 times positive 2. If minus times this plus here is minus, and then 1 times 2 is just 2. So I just expanded this bracket here. Now, somebody can have a different answer by multiplying the top and bottom of this final answer as we had previously here. So one can just multiply the numerator of this expression by minus 1, which we've been doing regularly. So I will have that p is equals to, somebody can choose to multiply by minus 1. So minus 1 multiply 2, sorry, let me change the color. Minus 1 multiplied by 2l 3t. Also do the same thing down in the denominator by doing minus 1 also, multiplying by minus q minus 2. Yes, doing this will give you a different form of answer, and I have it be equals to minus 1 times 2l is minus 2l, minus 1 times minus 3t, minus times minus plus 3t, all over minus 1 times minus q, minus 1 times minus q plus q, that is positive q, and minus 1 times minus 2 is plus 2, which we can write to be, anyway, p now becomes equals to, I can choose to write this first, this positive number first, that is 3t, yes, and then minus 2l, then all over q plus 2. So this could also be an answer. It's saying the same thing. It could also be an answer. So both of them are the same thing. Because this thing I just highlighted are the same thing, just that they are expressed in different terms. So we have p equals to 2 in brackets a plus b. Now in this case, as you can see, our a is on the right hand side. Yes, it's not on both sides. Our a is not on both sides, so it's just on one side, that is the right. So you can easily rearrange here by putting all the right to the left and all left to the right. Yes, it is much easier that way since it is found only on one side. So the next thing to do here is to open the bracket. I will have 2 times a is 2a, 2 times a is 2a, 2 times b here is 2b, and then equals to p. And so at this point, we will now take like terms. All the terms having a should be on one side, the rest goes to the other side. So I now have 2 and my a. So the rest term, that is plus 2b, will come over to the right and becomes equals to p. If plus 2b goes to the right, it becomes minus 2b. So we have to make a the subject of the formula. To get a here, it's just easy to divide by 2, dividing both sides by 2. So that 2 we cancel out 2, and I will have my a to be equals to, my equals to p minus 2b all over 2. That's the answer. You can choose to have a different form of answer as we've been doing by multiplying the numerator by -1 and also the denominator by -1. That will give you a different form of your answer. Now we have the next question. Make x the subject of formula or of the relation in 5xy minus d open brackets y minus x. So as you can see, the x is on both sides, so no need to rearrange. Just expand the bracket. Since the x I'm looking for is also in a bracket term, you need to expand the bracket. Now solving this, we then have it's 5xy is equal to d times y is dy, d times minus x is minus dx. Now we need to take like things in x. Everything containing x should come to one side, others go to the other side. So without wasting time, we have 5. Let me change the color of this. We have 5 and x and also y. Now minus d is on the right hand side, minus dx is containing x. So let it come to the left, become plus dx, become plus dx. And what we have on the right hand side is just only dy. Yes, I've taken like terms with x, so all x are on one side, while the others without x should be on the other side. So, without wasting time, you should know what to do here. What is common to both sides? What is the highest common factor? If you don't know, you use that tabular method. By this way, 5xy and then dx. So you can get the HCF from here as jumping roughly. So when you do this, I think what can divide at the same time here is x. X divide 5xy is 5y. X divide dx, that's d. What can divide at the same time here? Nothing. Nothing can divide at the same time. So we stop, and our HCF is x. So that is why I said the highest common factor here is just x. Now put the rest in brackets. So 5xy divided by x is just 5y plus dx divided by x is d, close the bracket, equals to dy. And now to get my x, I'll divide both sides by this bracket symbol. By this, it becomes divided by 5y plus d divided by 5y plus d. So that 5y plus d will cancel out here, and I will have x left. X becomes equals to 5y plus d in the denominator here, and I will have dy in the numerator. And this is my answer for this question. Answer is x equals to dy over 5y plus d. You can choose to rearrange. Sorry, you can choose to have another form of answer by multiplying the denominator and numerator by -1. Now, to solve this problem, we are asked to make x the subject of the formula. And as you can see, The x term are all in brackets. The x term or the letter s is in brackets, all of them. On the left hand side and also at the right hand side, they are all in brackets. So since we want to get this x and we are hiding in the brackets, we need to open that bracket. So let's begin from the left. A times b is ab. A times minus x is minus ax. And then I've cleared the bracket and we have minus b here. Now onto the right hand side, 2 times a is 2a, 2 times x is positive 2x. Yes. And now let's now take like terms in x. Let's take like terms in x. So be careful that this everything here is on the left hand side. So we need to take like terms. And also everything here is on the right hand side. So let's take like terms on x on the left hand side. Bring all the whole x to the left hand side. Now taking like terms, I already have an x term on the left, that is minus 3x. This minus 3x. We have another x term on the right hand side, 2x. But if 2x comes over to the left, it becomes minus 2x. And then we have equal to, because since we don't have any x term again, so we need to close with an equal to. Then over to the right, put all the terms without x on the right hand side. I have 2a first here. There are some terms that are on the left that don't have x, so move them to the right. Like we have minus b. If minus b leaves the left and comes to right, it becomes plus b. We also have ab. ab is having a positive beside it there, but it is invisible. If plus ab comes over to the right, it becomes minus ab. So as you can see, we're taking like terms in x. So now let's now factorize. As we know, now minus is common to both terms. Ax and 2x have minus on them. So bring out the minus. Also, they have x in common. So bring out the x. I believe we can do this now. So the uncommon thing should be in brackets. Now here, minus ax, let's see here, minus ax divided by this common minus x, and ax divided by the common minus x, minus we cancel minus plus, x we cancel x, I have a left. Also, minus 2x here should be divided by this common minus x. So minus 2x divided by that common minus x. The minus divided by minus is plus. And then x cancel x, we have 2. 2 then equals to 2a plus b minus ab. And for us to get our x properly, this minus must go away, this minus must go away, and also this bracket should go away. So to do that, we're going to divide both sides by the minus, as I've said, and also by the bracket. 10 there. So divide both sides by minus and bracket 10 there. Now minus, we divide minus, we have plus. A plus 2, we cancel A plus 2. So we now have x visible. X becomes equal to, we have 2a plus b minus ab all over minus bracket a plus 2. And this is our answer. You can choose to have a different form of answer like I've shown in the previous section. By multiplying the denominator and numerator by minus 1, yes, if you change the answer to a different form. So, this is our answer. And if you choose to, if you multiply the numerator and denominator by minus 1, to give us this answer, we have it to be x equals to, we have x equals to, if you try it, we have minus 2a minus b, then plus ab, which gives us a plus 2. If you multiply the numerator and denominator by minus 1, you have this answer. So this also is an answer as well for our question. And we have the next question. That is under relations involving fractions. So we have the first question there. Make m the subject of the formula in 1 over n equals to t over m. We have to make m the subject there. Now for fraction, whenever the term you are asked to find or to make subjects is in a fraction, you must clear the fraction. Yes, you must clear it. Just as we saw in brackets, those terms I was asked to make subjects, they were hiding in a bracket. So I had to clear out the bracket. The same thing, whenever the term you are looking for involves fraction, always clear the fraction. Yes. Either by finding LCM or you cross multiply. Now, but for this one, as you can see, we only have one fraction. We have one fraction on the left and one fraction on the right. So the best thing to do here is to cross and multiply. Because whenever you have such fraction, just one on the left and one on the right, you always cross and multiply. So we start by doing m times 1 is just m. M times 1 is just m. Then equals to t times n is nt. And as you can see, this is our final answer. We have made m the subject because m is now alone on one side and other letters are on the other side. So m is equals to nt. That was so simple. Now, question 2. Given that L is equals to 2R plus 1 over 2xr, make x the subject of the relation. Now, as you can see, it involves fraction. This one involves fraction. So, to solve this fraction, what can we do here? Now, you will agree with me that this can be written as L equals to 2R plus half xr means half times xr, like this. Half xr also means 1 over 2 times x times r. Yes, if you can call here as over 1 and here as over 1. So 1 times x is x, x times r is xr. So we have x, so we have x r. Yes, and under 2 times 1 is 2 times 1 again 2. So half xr and the same as xr over 2. The same thing. So now what can we do here? Let's call here over 1 and here over 1 and here over 1. Okay, now don't be too quick to cross multiply, because if you cross multiply this way, that means you are leaving this man unaffected. So we did not touch this 10, this fraction 10 here. So it's improper doing or multiplying by crossing. Now, you only multiply by crossing whenever you have just two fractions, as we saw in the example 1. Whenever you have just only two fractions, one on the left and one on the right. But when you have more fractions, please use LCM. So what is the LCM of 1, 1 and 2? What is the LCM of 1, 1 and 2? It's just 2. It's just 2. 2 is the LCM here. So in this case, I write that my LCM is 2. And what does that mean? Now I'm going to use 2 to multiply each of the fractions. I'm going to use the LCM, which is 2, to multiply each of the fractions. So let me write them out. These are the fractions here. We'll have okay, let me write the LCM first. The LCM is 2. So 2 will multiply L over 1 equals to the LCM again, which is 2, should multiply 2r over 1, and also we have plus the LCM also, which is 2, should now multiply x r, where x r over 2. So like this. As you can see, each of the fractions, L over 1, 2r over 1, and xr over 2, each of them, I multiply them with the LCM. I multiply each of them with the LCM. So that is how you win them. Now what's next? Let's now divide here and multiply. L divided by 1 is 2L. 2 times L gives us 2L equals to 2R divided by 1 is 2R. 2R times 2 is 4R plus, I think we can divide here. Yes, 2 down here can cancel 2 up here. One more time. Yes, 2 in itself 1, 2 in itself here 1. So we now have xr divided by 1. So xr divided by 1 is still xr, and xr times this one outside here is 2xr, because if anything multiplied by 1 is the same thing. Now I have xr. So we've now declared the brackets. You see, it is not like our first case when we had linear sums. Yes. So for this part now, you can see the x is on the right hand side. Only I don't have this anywhere again, so I can choose to rearrange by calling all my left hand letters right and calling all my right left, like this. I have 4r plus x r equals to 2l. Then I will take like terms. I'll move all 10 that does not have x to the other side. Don't forget that 4r here is positive. 4r is positive here. So I now have xr left here. xr here equals to 2l. If plus 4r comes over somewhere here, it becomes negative 4r. And then to get my x proper, I'm going to divide both sides. To get my x, I'll divide both sides by r. Dividing both sides by r. So that's r, cancel r, and I have the x visible. X is now gotten to be equal to x is now equal to 2l minus 4r over r. So this is my answer for x. X is equal to 2l minus 4r over r. So you can choose to have a different form of answer. I've told you, whenever you have a fraction, you can choose to have different form of answer by multiplying the numerator by minus 1 and also the denominator by minus 1. Now, let's see the third question. Given that r is equals to half open bracket a plus b close bracket k, find k in terms of r, a, and b. Find k in terms of r, a, and b. So we have to find k here. And as you can see, our k is very unique there. And there's no point trying to open the bracket. Yes. You know why? Because the k we are looking for is not in the bracket. It's outside the bracket. Had it been we are asked to look for either a or b, yes, I would have needed to expand that bracket. Yes. If we are asked to make a or b the subject formula, then I would need to open the bracket. But since we are finding k, and k is not in the bracket, so please don't expand. Now let's rewrite this equation like this. I would have done this in a simpler way by dividing or multiplying both sides by 2 over a plus b. Yes, that would have been faster. By multiplying both sides by 2 over a plus b. But you might not get it. Yes, mostly if you're my student in my school and this is your first time saying this, you may not get it that way. So let's just do it gradually, and it becomes r equals to this whole thing here. As you can see, what this means is that 1 over 2 is multiplying by a plus b, and this is c multiplying by k. This is what it means. Yes. So I can easily call here over 1, and easily call here over 1, and I will have this to be multiplying the numerator 1 times a plus b in bracket times q is 2b. R equals to 1 times a plus b is still a plus b, and a plus b multiplied by q, it should be q. Should be q, open bracket, a plus b, close the bracket, all over 2 times 1 is 2 times 1 again is 2. Very good. As you can see, I can call it over 1, and we just have two fractions, one on the left and one on the right. And like I told you, for such fraction, you would have to cross and multiply to be more faster enough. So crossing and multiplying, like this, I will have k bracket a plus b. All these things here multiplying by 1 will still give us the same thing, because if anything multiplied by 1 is the same thing, I have a plus b equals to, and 2 times r is just 2r. So to get my k here, I'll divide both sides by a plus b, dividing by a plus b, and finally our answer becomes that this cancels this, and that k and k becomes k equals to 2r over e plus b. Now we have the fourth question. Make f the subject of the relation in x equals to df plus dy all over c minus 2f. Now, firstly enough, to solve this problem, as you can see, we have just two fractions, one on the left and one on the right. We have two fractions here. This is the first fraction, and this is the second fraction. So the best way to solve is crossing and multiplying. Yes, because we want to clear, whenever you have a fraction, always clear the fraction. So let me plug here over 1. So I'll have to cross and multiply. Now, df plus dy times 1 is still the same thing. Anytime multiplying by 1 is the same thing. So we'll have df and then plus dy equals to, now we have c minus 2f times x. So that should be x. So c minus 2f times x should be x itself, multiplying c minus 2f. Yes, so that is it. So df plus dy multiplied by 1 is the same thing, because anything multiplying by 1 is the same thing. But c minus 2f times x should be written this way, as x in bracket c minus 2f. So what do you observe? The f we are looking for is in the bracket, although one is visible on the left hand side, but this f is still in the bracket. So we need to bring it out. Whenever anything we're looking for is in the bracket, we bring it out. And I'll have for the left hand side, I have b f, df, I have plus dy equals to x times c is cx, x times minus 2f, minus 2f x, yes, x times minus 2f minus 2fx. So Bring all the f together and take other terms not having s to one side. So I think this is my left hand side. On the left we have just these two here on the left hand side, and here we have just this. So we have just this on the left hand side and this on the right hand side. So take the f term from the right to the left. It becomes negative. It becomes positive because it is negative here already, I minus 2fx. So I'll still have bf left here. I want to bring all the whole f terms together. I have bf. Yes, there is a term containing f on the right, as I've said, and that is minus 2fx. If minus 2fx crosses and comes to the left, becomes plus 2fx. Yes. So these are just the two terms having f. The rest should go to the right hand side. Other should go to right hand side. Already on the right we have cx. On the left we have dy. dy does not have f. So take it to the right. It becomes, and it's positive on the left. As you can see, it's positive here. So when it goes to the left, when it goes to the right, it becomes minus dy. And now, as we've been doing, you see these two terms, they have something in common. They have f in common. So I'll have to bring that f, which I'm looking for, in the text. You put the rest terms in brackets. Bf divided by f is b. Now plus 2fx divided by f is plus 2x. Then equals to cx minus dy. Now finally, to get my f, this bracket term beside f needs to go out. By dividing both sides by that term, I'll have b plus 2x all over b plus 2x. So that b plus 2x will cancel itself here. And finally, our f is now equals to cx minus dy all over b plus 2x. So this is our answer. You can choose to have another form of answer. Like I said, whenever you have a fraction, you can multiply the numerator and denominator by minus 1 to give you another form of answer. Of course, for this question, another form of answer could be given as our answer can still be dy minus cx all over minus b minus 2x. So this can still be our answer. That is, if you multiply the numerator and the denominator by minus 1. Now let's look at question 5. We're asked to make V the subject of the formula in 1 over f equals to 1 over v plus 1 over u. So to solve this, we asked to make this subject. And whenever you have fraction, always clear the fraction. Whenever you have a fraction, always clear the fraction. So, that makes it quick to say cross multiply. No. That would be a wrong start, because if you do that, 1 over u is now unaffected, which is improper. So, what we have to do first is not crossing and multiplying by finding the LCM. So what is the LCM of F, V, and U? LCM of F, V, and U. Now the LCM should be LCM of F, V, and U should be F, U, V. Yes, I did it in the alphabetical order. Yes, because in the alphabet, F comes before U and then V, and then V, sorry. So F, U, V. If you write F, V, U, it's the correct thing. But I have to do it according to the alphabet. So that's my LCM. Now for this LCM, multiply each of these fractions by the LCM. Multiply each of these fractions. That is 1 over F, 1 over U, and 1 over U. Multiply each of them by the LCM. And multiplying it, we have this. So let's see what can cancel out. So F will cancel out itself from here. V will cancel out itself from here. And U will cancel out itself from here. So what do we have left? We have UV times 1, that is 2UV. Then equals to, we have FU times 1, that is 2FU. Then plus, we have FV times 1, FV times 1 is 2FV. So we have cleared the fraction. Good. It now has the form of the linear relations. So you are asked to make these subjects here. You take like terms in V, bring all the whole V's together, and I have I have U, V, I have plus FV on the right hand side. Because it becomes minus FV. So I don't have any V term again. So those without V terms should be on the right hand side. I have FU just remaining there. So as we've always done, we have to factorize. V is common to both sides. So bring out that common V. And the rest should be in brackets. UV divided by V is U, minus FV divided by V is F. So equals to FU. So to get my V, I divide both sides by U minus F. Divide both sides by U minus F. I have U minus F here. U minus F. So U minus F will cancel out. And therefore, our V comes equal to FU this becomes FU all over U minus F. This is the final answer. Unless you want to get another form or another form for this answer, which, as we've said, we are multiplying the numerator and denominator by minus 1. You get a different form of answer. So I believe you should be able to try question 6 and 7. Just try question 6 and 7 on your own. And also, these questions here as well, you can add them also. So you can pause the video and copy them down, and then try them on your own also. 1 to 6. Now we have relations involving powers and roots. When we are dealing with powers and roots, and let's be fast enough. So as we make R the subject of the relation A equals to pi R squared, as we make R the subject of the formula. So as we have this here, A equals to pi R squared. So you can choose to rearrange it because R is found only on one side and R is on the right hand side only. Like I've told you, whenever you have the letter you're looking for on the right hand side only, you can choose to rearrange. But if you find on both sides, there's no point to rearranging, or if it is found on the left side only, no point to rearranging. So let's rearrange this for convenience sake. We'll have an R squared equals to, sorry, we have pi R squared, which are rearranged to be on the left, and A should be on the right hand side. So A equals pi R squared, same means pi R squared equals to A. And to get the value of my R, first I must divide both sides by pi. Divide both sides by pi. I divide both sides by pi. Now pi will cancel out itself, and we have R squared left here equals to A all over pi. Now how can we take out this square? For me to remove a square, I need the square root. To remove a square, I need the square root. And also to remove a cube, we need the cube root. This way. To remove a fourth power, we need the fourth root. To remove a fifth power, we need the fifth root. And so on. In likewise manner, to remove a square root, I need a square. To remove a cube root, I need a cube. To remove a fourth root, I need a fourth power. And to remove a fifth root, I need a fifth power. So they work vice versa. So for me to remove this square here, I must take the square root on both sides. And we will have R to be equals to A over pi. And when I take the square root on both sides, the square will cancel the square root, and we now have R left. And we have it that R is now equal to the square root of A over pi. And this is our answer. R is equal to the square root of A over pi. So let's look at the second question. Given that V squared is equals to U squared plus 2AS, find U in terms of V, B, and S. So, as you can see, they ask to make U a subject. Now, to make U a subject, you can notice that U is actually on the right hand side. Since it is just on the right hand side, I can choose to rearrange. And I will have U squared plus 2AS equals to V squared. I just had to take everything on the right to the left and all left to the right. without changing their signs. That's what rearranging is all about. So, to solve this problem, now I want to get you, but I need 2as to go away. So, I will have you, then squared. So, plus 2as should go away, more precisely on the right hand side. I will have b squared. So plus 2as travels to the other side and becomes minus 2as. And now how can we take out? We're left with this square here on u. So how can we take out the square on u? Since u is having a square, to remove a square, we always take the square root on both sides. To remove a square, always take the square root. Therefore, I have that u squared, which is equals to u squared minus 2ax. Now taking the square root on both sides, taking the square roots on both sides. We know that the square will cancel the square root, and therefore I have my u is equal to the square root of v squared minus 2ax. And this is your answer. Now, don't be tempted to split this, because some of you would want to split this by saying that the answer is still the square root of v squared minus the square root of 2ax. And then you tell me that the square will cancel the square root. Please don't try it. You don't split roots when you are subtracting or adding. Yes. I think if you are also adding here, you also should not split the roots or the contents under the roots. You don't split it. You can only split if you are multiplying. At least if you had if your answer was to be the square root of v squared times 2ax. Yes, in this case it is allowed to split. You can have the square root of v squared times the square root of 2ax, which I can cancel the square and the square root, since they can cancel each other. And then my answer becomes v root 2ax. Yes, you can do the same while you're dividing. We have this square divided by 2ax, all under square root, all under the square root form. It's still with us moving square root of v squared divided by the square root of 2ax, which the square can cancel the square root. And I have that will be v divided by the square root of 2ax. Now this is the only place where you can split when you are multiplying or dividing. But if you're adding or subtracting, please you don't split. So therefore our answer to this question is just this only. So we have the next question here. Now if you have noticed, I removed the previous question. I removed it. That was for that question, it requires the quadratic formula to solve it. So, but I think I will do that in my next video. Yes. So I would want to, since we are still learning this, that was why I skipped it. So you can understand all the basics before entering that part. So it requires the quadratic formula. So let's look at this particular question here. Make G the subject of the formula of relation and T equals to 2 pi times the square root of L over G. Since there is no sign between 2 pi and the square root, it's meaning that it means that they are multiplying. So we have it here. Let's divide it here. Now, the first thing to do here is we have to make G subject, but G is under a square root sign. G is under a square root sign. So what do we do? G is under a square root sign. Before I proceed, I need to take 2 pi out. Yes, you can choose to do it in 2 ways. Either by multiplying 2 pi by its reciprocal, that is 1 over 2 pi. Yes, for 2 pi here, for 2 pi, the reciprocal of 2 pi is 1 over 2 pi, right? Multiply 2 pi by 1 over 2 pi, copy over 1. Now have that 2 pi will cancel out one time, and then I have 1 times 1 equals to 1 all over 1 times 1 equals to 1, and then 1 divided by 1 is just 1. So I can choose to multiply both sides by the reciprocal of 2 pi, so that 2 pi can go away from here. But the other way is to divide. The other way to avoid multiplying by reciprocal is just by dividing both sides by 2 pi. So I'll write it here. Let's see. Divide both sides by 2 pi. So like this, dividing both sides by 2 pi, dividing here also by 2 pi. So 2 pi, we cancel 2 pi here, and then I have on the left hand side T over 2 pi equal to, what is left on the right is just L over G, as you can see. We have L over G now left on the right hand side. So what next? Our aim is to get G, but G is under the square root sign. Our aim here is to get G, but G is under a square root sign. So what can we do? To take out this G from here, I must defeat the square root. To take out G, I must defeat the square root. So how can I remove the square root? To take out the square root, I must square both sides. Yes, to remove the square, you need the square root, and to remove the square root, you also need the square. So how do I know? I'll have 2 over 2 pi equal to, I'll have L over G. So this is just the previous equation. So I'm going to square both sides like this. I'll square both sides of this equation. Square both sides, so that the square will cancel the square root. And then what do we have left? We now have 2 all over 2 pi all squared on the left, and then equal to, on the right we just have L over G. We have L over G. So what's next here? What can we do here? We can choose to expand this. Now this left hand side actually means that this square belongs to both t and 2 pi. How do I mean? I can write this as t to the power 2. Don't forget that this 2 as power also belongs to 2 pi, still all squared, equals to L over G. Now as you can see how I just splitted it. So if still go further, I have 2 square all over. Now what does 2 pi all squared means? 2 pi all squared means 2 pi times 2 pi, of which 2 times 2 is 4, and then pi times pi is just pi squared, equals to L over G. So what next here? At this point, I'm going to cross and multiply. I'll cross and multiply. Note what we have to find, G. So G times T squared gives us G T squared equals to L times 4 pi squared should give us 4 pi square L. And then what's next? How can we get our G? To get G, we need to take out T squared. How? By dividing both sides by T squared. Dividing both sides by T squared. So T squared can cancel out T squared. And then I have G remaining to be equal to, answer is now 4 pi square L over T squared. Now this is the answer. But you can have another form again. You can choose to do something quite different. If you start here, you'll see for it. So my answer can still be as 1. G equal to, now I can choose to rearrange. I will have 4 L and then pi squared over L squared, which can still be written as 4L. Since these two have square in common, I can factorize and I have pi L over L all squared like the law of indices. But if you don't understand this, just get the first answer you get from here. So let's take a look at the fourth question. Make G the subject of the relation in T equals to 2 pi plus the square root of L over G. Now, you can notice that 3 and 4 are quite similar but not the same. Question 3 and 4 are quite similar. So that the only difference is that between the 2 pi and the square root of L over G, there is a plus sign. Whereas, as for number 3, there is no sign between 2 pi and square root of L over G, which tells us that we are multiplying, just as we did previously. Now, the two, question 3 and 4, are not meant to be handled the same way, but quite in a similar way. Since we are adding, in this case, there is no point dividing both sides by 2 pi. Since we are adding here, there is no point dividing by 2 pi. It is very easy to separate 2 pi from the square root of L over G. How can this be done? I can choose to rearrange if you want to. You can choose to rearrange. I'll just press 2 pi to the left at once. But let me write it this way. We have L over G, then equal to, we have to pi first. Let's try to pi first. Plus square root of L over G. Yes, and then equals to T. So, since these two are not multiplying, there is no need dividing both sides by 2 pi. I can easily take 2 pi from the square root by crossing over. And then if I cross over, we have L over G, the moment on the left hand side. Cutting 2 pi over to the other side, I will just have T minus 2 pi left. I will have T minus 2 pi left. So what next? What can we do here? How can we get G? G is under a square root sign. To get G, I need to remove the square root. Yes, to get G, I need to remove the square root. So how can I remove the square root? By squaring both sides. I'll square both sides and I'll have the square root of L over G equal to T minus 2 pi. So, squaring both sides. The square will cancel the square root. Then I'll have L over G. Change the color of this G. I have L over G. Then equal to, we now have T minus 2 pi all squared. Fine, so now there's no point trying to expand these brackets. There's no need for that. So I can now call here over 1. So what next? I have to cross and multiply. Note what you have to find is G. So to get G, I multiply G by this bracket. I'll have G and the bracket, that is T minus 2 pi all squared equals to L times 1 is L. We are almost there. How can we now get G? As you can see, these two are multiplying, so G can be gotten by dividing both sides. So I'll divide both sides. For me to get my G, this whole bracket term must go away. So I'll divide both sides. That whole bracket term then, that is T minus 2 pi all squared all over T minus 2 pi all squared. And then finally, we now cancel the common factors here. Therefore, G has equal to L over T minus 2 pi all squared. So this is my final answer. Now you can check. The rate is our fourth answer to the third one to see the difference. See how they are different. Yes, for this one we are having a sum or a plus sign between 2 pi and the square root. But for the third question, we are having a multiplication sign. So you can see how we will handle it. There is no formula to solving this problem. It's just you need to know what to do at every point. Practice more and get the answers. So let's look at the fifth question. If P equals to n over r squared plus k, find an expression for r in terms of P, n, and k. So in short, we are asked to make r the subject of the formula. So how can we make r a subject here? As you can see, r is under a fraction, so we must let the fraction. How? Let's call here over 1, and also call here over 1. So let's find the LCM of all the denominators. What is the LCM of 1, r squared, and 1? It's 2r squared. So we're going to multiply each of the fraction by the LCM. That is, putting the LCM by the side of this fraction somewhere here, putting the LCM just there. So since the LCM as well is r squared, we'll have go this way. LCM is r squared. So multiplying by p divided by 1 is 2p equals to the LCM is r squared. And then we have a fraction there that is n over still the same r squared plus the LCM is r squared. We have k divided by 1 is 2k, so the LCM multiplies by k. So r squared times p, r squared times p is p r squared. I have p r squared equals to r squared, we cancel r squared here, we have n left. R squared times k is p, sorry, plus r squared times k is p r squared. So don't forget what you're asked to find. You're asked to find r squared. These things here, like we have to find r, sorry. Now how can we get r? Let's take like terms in r here. Let's take like terms in r. All r should come to one side. And I have p r squared. We have an r term on the right hand side, that is p r squared. It's positive. When it comes to the left, it becomes negative minus p r squared, then equals to n. As we know, we can factorize here. Don't forget what we are asked to find. We are asked to find r squared. So r squared is common to both sides here. R squared is common to these two sides. So I can factorize r squared out. So p r squared divided by r squared is p minus p r squared divided by r squared is q equals to n. So we are almost done here. To get my r, I must take out p minus q first before the square. So how can this be done? By dividing both sides by p q, dividing both sides by p minus q. So that p minus q will cancel out here, and then we have r squared to be equal to n over p minus q. So we are almost done. To get our r, the square must go out. The square must go out. So, of course, by now you should know what to do here. For me to take out the square, we must square root both sides. So, I'll square root both sides this way. The square will cancel the square root. Therefore, our r becomes equal to square root of n over p minus q. This is our answer. Now let's look at this sixth question. Make x the subject of a relation and x over y minus z equals to y by 4x times a minus y minus 1. Now, don't be lost here. This is a fraction. So, whenever you have a fraction, let's clear the fraction. So, how can we clear the fraction here? Just by cross multiplication. So, cross multiplication. Now, I have x. If x multiplies 4x, then in the bracket here, I have x times 4x here is 4x all squared. Then because x times x here is x squared. So it's going to multiply by 4. So we'll have 4x squared. And there is a bracket attached to it, a minus 1. Then equals to, we have y now multiplying y minus z, y multiplying y minus z. Don't forget what you asked me subject. It's just x. I have to multiply by crossing. Now x here multiplies with 4x here. X times, what I did was x times 4x times the bracket a minus 1. So with this x cancel this x, we have x squared, then times the 4 here with 4x, and then with the bracket a minus 1. So that's it. Now we need to get x, and as you can see, they are all multiplying here. 4 is multiplying x squared and x squared multiplying a minus 1. So how can I get my x first? To get this x first, I need to take out this 4 and this bracket 10 first before anything. I must take out 4 and that bracket 10. How? I'll divide them both sides. So I'll divide both sides by 4 and then that bracket 10 a minus 1. Divide both sides by 4 and then the bracket 10 a minus 1. Now 4 will cancel out 4. The bracket will cancel out the bracket. And as you can see, x is now visible. And I have x squared is not visible equal to y times y minus z all over 4 brackets a minus 1 close brackets. So you're not done yet. Now you should know what to do here at this point. I want to take out that square root. I want to take out the square root. So how can we take out the square root? And as you know, how can I take out the square? And as you know, to remove the square, you need the square root. To take out the square, you need the square root. And so we then have x squared equal to y times y and z all over 4 times a minus 1. So, like I said, for this square to go out, we must take the square root on both sides. So I have the square root on both sides to be like this. The square will cancel out the square root, and then we have x equal to the square root of y times y minus z close brackets all over 4 and a minus 1. So this is your final answer. Now you can choose to stop here, but I think I will add something. I will drag a 4 in the denominator. I will drag a 4 in the denominator, and easily take the square root of 4. From there, let me show you. So I can rewrite this my answer. I had you as this. If you observe, there is 4 in the denominator. Although while I'm doing this is because 4 has a square root. That is 4 is a perfect square. So if there was a 5 here, then no need for this. But since I can simplify 4 under the square root, so I need to do this. Although if you stop at where you stop, you're still correct. But I can still rewrite this as the same thing. Yeah, because for the numerator 1 times y times 1 minus z, if 1 multiplied by anything is the same thing, so 1 times y minus y minus z should still give us y bracket y minus z all over. If 4 multiplies a minus 1, I'll still have 4 brackets a minus 1. So you see, it's still the same thing. So now what else can we do here? I can split this. By saying that this simply means the square root of 1 over 4 times the square root of y brackets y minus z all over a minus 1. So finally, for 1 over 4, what is the square root? Of course, what is the square root of 1? It's just 1. So over what is the square root of 4 is 2. So I am multiplying by the square root. We have that our answer becomes 1 over 2 times the square root y open brackets y minus z round over a minus 1. So this can also be a possible answer as the one we had before. It's the same thing. So let's look at the seventh question. Make Q the subject of the relation and T equals to the square root of PQ minus R squared Q over R. So what can we do here? Observe that Q is under a square root, and for us to get Q, we must take the square root out. And so how can we take out the square root? As you know, to take out the square root, we must square both sides. To remove the square root, we must square both sides. And so squaring both sides, we have to square the square, we cancel the square root, and we are left with t squared equal to PQ minus R squared Q, then all over R. So we are still having a fraction here. So if we declare the fraction, let me put here over 1. Now everything in the numerator, PQ minus R squared Q, if we multiply it by 1, we will still have the same thing as PQ minus R squared Q, because anything multiplied by 1 is that same thing. And then equals to TR times R, sorry, T squared times R, the R T squared. So what can we do here next? We want to find Q. To find Q, let's factorize on the left hand side. Since Q is in common, we want to get Q. So Q is common, let's get Q out and put the rest in brackets. PQ divided by Q is P minus R squared Q divided by Q is just R squared. And then equal to we have R T squared. So how can we get our Q? To get our Q, this bracket term must leave. So I will divide by the bracket term. Q minus R squared all over P minus R squared. So that P minus R squared will cancel itself here. And then we have Q left. Then equal to the final answer becomes RT squared all over P minus R squared. So this is our final answer. Let's look at the last question. Make A the subject formula in P over Q equals to 3 over 4. Now we are asked to make A the subject formula, and A is under a square root. A is under a square root. And this somehow might look complicated to your eyes, but it is not. Take off the things you need to take off gradually. How can we take off 3 over 4? How can we take off 3 over 4? To take off 3 over 4, I would have said let me divide both sides by 3 over 4, but you might make a mistake. It's allowed, but Since it's a fraction, let's multiply by the reciprocal. Yes, since it is a fraction, so I'll say multiply by the reciprocal of 3/4, which is equals to, and for 3/4, what is its reciprocal? Is 4/3. So with multiplying both sides by this reciprocal, it gives us, it will be a better way for us to do. So let's see, 4/3 multiplied by P/Q, like this, equal to 4/3 again being multiplied by 3/4 all square root of x plus a all over x minus a. Please do not be confused. I'm trying to take out 3/4 here for simplicity's sake. And to take out 3/4, the best way is to multiply by its multiplicative inverse, or you can call it the reciprocal. And this is why I multiplied by the reciprocal of 3/4 on both sides, that is 4/3. As you can see, for PQ, multiply by 4/3, and for the whole of 3/4 and that square root, multiply them by the same 4/3. And watch how it becomes simpler. 4/3 times P/Q. That is 4/3 times P/Q. Now what can we have here? 4/3 times P/Q. You get simply 4 times P is 4P. 4 times P is 4P over 3 times Q, 3Q. So 4/3 times P/Q give us 4P over 3Q, then equal to, of course, as we can see now, 3 will go in itself one time, 3 will go here one time, 4 will go in itself one time, 4 will go here one time. What do we have left? 1 times 1 is 1 over 1 times 1 is still 1, and 1 divided by 1 is 1. So everything here becomes 1. And if 1 multiplies by this square root, it's still the same square root, because if 1 multiplies anything, or if anything is multiplied by 1, we still have the same thing. So this whole square root will now multiply by 1 to still give us the same thing, which is x plus a all over x minus a. So that's the first step. So what next can we do here? What's the next thing to do here? The next thing to do here, we want to get a. That should go in your mind. So getting a requires that we take off the square root. And how do we take off the square root? Is by squaring both sides. By squaring both sides. So squaring both sides, we have 4P over 3Q equals to the square root of x plus e x plus a all over x minus a. So since I want to take out the square root, I must square both sides of this. I must square both sides so that the square root cancels the square root. And then what do we have next? We have 4p over 3q all squared simply means 4p all squared all over 3q all squared. And then what do we have now? We now have x plus a showing up all over, we now have x minus a also showing up. So let's simplify this. What is 4p squared? 4p squared means 4p times 4p. 4p times, that should be 16p squared over, what does 3q all squared means? 3q all squared means like this. 3q all squared means 3q times 3q. That is 3 times 3. That is 3 here times 3 here is 9. Q times q is q squared. So 3q all squared is 9. Sorry. 9q squared equal to x plus a all over x minus a. Now what can we do next here? As you can see, the a is, they are under a fraction. So a is found in a fraction. So how can we take out this fraction? To clear the fraction, I need to cross and multiply. Cross and multiply so that 9 squared multiplied by x plus a like this. 9q squared multiplied by x plus a is equal to 16p squared multiply x minus a. 16p squared multiplied by x minus a. So what next? The a and the bracket, we need to expand the bracket. We need to expand the bracket so we can have like terms in this. So 9q squared times x should be 9q squared x. 9q squared times a will be plus 9q squared a or 9q squared equals to 16p squared times x should be 16p squared x, then minus 16p squared times a should be 16p squared a. Good. So having expanded the brackets, let's now take like terms in a. All terms containing a should come to one side. other should go to the other side. And from the left hand side, we have a term having a, that is 9, q, let's do it as 9a, sorry, let me highlight the e very well, 9a q squared. There is another term having a, but on the right hand side, that is minus 16p squared a. So if minus 16p squared a comes to the left, it becomes plus 16, let's write it as 16a p squared, a p squared. It is now equals to, other terms without a should come to the right. On the right here, I already have 16q squared x. 9q squared x. 9q squared x should come to the right and become minus 9q squared x. So, and what can we do here? You see the a, we have a in common. So, you can write out a this way, bring out a, and the rest should be in brackets. The rest should be 9a squared divided by a should be 9q squared, then plus 16a squared divided by a should be 16p squared, and equal to. So what's next here? What can we do here? I don't want to confuse you. I would have done something here that is the difference of two squares. But let me highlight this part. I will come back to it. Let me highlight it. Let me call here question 1. I'll come back to it. So let's continue. It becomes 16p squared x minus 9q squared x. So obviously getting my a is now simple, because I'll divide this side by 9q squared plus 16p squared all over 9q squared plus 16p squared. So the 9q squared plus 16p squared will cancel itself here. And then we now have a of equal to, our a is now equal to 16p squared x minus 9q squared x all over 9q squared plus 16p squared. So this is our final answer. We've gotten our a. So this is the answer. 16p squared x minus 9q squared x all over 9q squared plus 16p squared. Now, like I said before, okay, let me use from this part here. that I will highlight now in this part here. And you could apply the difference of two squares. At this place where I stopped, as my final answer is actually the answer. But you can still do something again. You can still go further again. At least if you wish to. So how can I still go further again? Let's treat this term separately. 16 p square x minus 9 q square x. Now first of all, let's take out what we have in common. We have x in common, so now have 16p square left minus 9q squared. Okay, now notice that the term in bracket is a difference of 2 square. It is a difference of 2 square. How do I mean? I can write it that I can write everything as a square number. So 16 means 4 squared, and I have q square minus 9 means 3 square, and I have q square here. So by difference of 2 square, you can write this as 4p minus 8q times 4p and then plus 8q. Yes, so this is actually what I was trying to show you. I can write this whole term here as a difference of 2 square. So finally your answer could still be A equal to like we have in the numerator a difference of 2 square. It cannot be written as x in bracket 4p minus 3q in brackets. Open bracket again, 4p plus 3q. Then all over 9 q squared plus 16 p squared. So this is also a possible answer. This could also be a possible answer. Okay. Thanks for watching. You could try other questions as well. And then ask questions where you are confused. Thank you.